So my name's Tully. Let's see, I've been working in electronics manufacturing for more than a decade. I've done a lot of work in Asia. I worked at OpenMoko, the world's first open source smartphone. Oh, okay, is it a little better? Okay, I worked at OpenMoko. Worked at Seed Studio. I've been working in China since 2005. And I've been really excited working with electronics manufacturers who are excited about electronics, or suppliers, or people who are excited about electronics. And one of my favorite people is Benjamin James, because he is a fanatic about exciting, creative lighting products. And Benny was first, let's see, back in 1999 was when the first EL wire was on the playa. And Benny was the first person to be able to sell EL wire to people under the name Cool Neon. And he would sell it to you at any length. Before that, people had to buy it from Israel, and they had to buy it in reels. So he's a major landmark person among those of us who care about creative lighting. He's the one who brought electroluminescent wire as Cool Neon to all of us so we could use it. And now, because he's always traveling the world and discovering new stuff, he's now bringing these new LEDs to America. And I live in Shenzhen, China, and so I help him out when he's not there. But he's the person who goes to China, visits all the factories, visits the chip suppliers, and finds out the very best stuff, and then brings it back. And so if you're among those who really care and are passionate about LEDs, there's nobody like Benny to go to. And so the world has taken notice. So like for let's see, if you go back to the Olympics, the Olympics just in Russia, during the opening ceremony, they were working with Benny for the costumes. And for the commercial, there was which one was it, MasterCard? MasterCard commercial, they had a suit, there was an LED light up suit the snowboarder was wearing. Benny built that suit. And then before that was the America's Got Talent. And there was a group called I Illuminate. It was a dancing clothes with luminescent with Cool Neon. And Benny was working on those. And there was another group, but they were a finalist, and another finalist, Lightwire Theater. They made dinosaur costumes. That was with Benny's work also. And then a lot of the famous singers you might recognize. Katy Perry has used Benny's work. She made these big peacock feathers that she wore at one event. And Beck and Kanye West has worn his lighting. So like the list is, let's see, anybody miss anybody? Oh, and then for commercials, Honda, he decorated a car for Honda. And who else? And Philips. Philips owns probably most of the patents for RGB LEDs. He's worked on a commercial with them where he's got a light up surfboard in his suit, and it hasn't come out yet. You're going to see that soon. So anybody who's passionate and wants the best LEDs, they go to Benny, basically, the whole world, right? So that's my intro for Benny. So without further ado, I want to introduce Benjamin James. All right.
Hi, thank you very much. I certainly do enjoy lighting. It's, as Confucius said, if you give a person a job they love, they'll never work another day in their life. And when I create a product line that is so beautiful, my projects I enjoy, but my customers do such amazing things that exceeds my creativity by an order of magnitude. And by providing artists and technical people with a product line that they can explore their creativity with and rely on, it provides tremendous pleasure. And as Tully said, since 1999, I've been providing Cool Neon electroluminescent wire to the Burning Man community and beyond, all the way to the Sochi Winter Olympics, which was beautiful. The Swan Lake was a perfect example of a company doing all the creative work, and we supplied the high quality product for them to bring their vision to reality. The addressable LEDs we launched here 3 years ago at the Maker Faire, and it has been a glorious success. We brought a technology that existed in China that was closed source, and we launched it completely open source. So all of our codes are at GitHub and on our website, and my dear friend Chris DeVries has written wonderful open code for addressing our pixels. And let's see what pictures I have here. This is Truth is Beauty at Burning Man, one of the tallest sculptures ever at Burning Man. She was filled with 2,666 pixels, all individually addressed. It was a custom install. I mean, it was a custom build. They were separated by 2 feet, running off of a BeagleBone. And before I get too technical and talking about BeagleBones and Arduino and code, I'd like to ask, how many of you are Arduino programmers or C programmers? And I imagine about twice as many of you own an Arduino and maybe haven't quite done too much with it. I fell in the category of not being a C programmer when I adopted this product line, and or when I developed this product line, and now, well, at the launch, I had simple controllers that controlled the lights in a beautiful fashion, and let me switch to. There we go. I had simple controllers that controlled the lights in a beautiful fashion, and gave them to many of my friends that came to the booth, and they all said, if I can control it with an Arduino, I don't need your controller. I'm completely content driving these lights with an Arduino. And within a few weeks of the launch, my friends were all emailing and developing the library that are now driving the Arduino. I mean, that are driving our pixels. And that's all posted. So I might be losing some of you. So I'll get right to describing what's going on the pixels that you see around. There is, each one is addressed with a full 8 bits, a full byte of data for the red, the green, and the blue. So as you see the color coming through, when you see blue, that is no power to the red and the green, and when you see red, that's no power to the green and the blue. And all that data is being sent from various controllers down the string, and each pixel is genius in that it doesn't know who or where he is. The data packet is generated, and it comes barreling down, and the first pixel strips off red, green, and blue data, latches, and then passes the data down to the very next pixel, who thinks he's the first pixel. Strips off red, green, and blue, and so on. And this is done at a megahertz clock cycle. So the screen in the dark room, I should address that our booth is the very tall 2 screens in the back of the dark room. And I should also say, all of our pixels this weekend are half price for Maker Faire. So all of those pixels are being serially addressed. The widest screen is 1,250 pixels, and they're being addressed from the first pixel all the way through to the last pixel, one continuous data train. And the pixels have 4 lines, the total control lighting pixels, and what the 4 lines are on the outside is 5 volts plus ground, and then data and clock. So to go back to the Arduino, the Arduino has I/O, and the Arduino generates an SPI signal, which is a pulse of data that indicates what the data for red, green, and blue is. So there's a clock line and a data line, and they sync up and can run at a tremendously high and reliable rate. And this year we're adding to our line a less expensive and a little bit simpler version of the Pixel that only has a data line. And it is quite beautiful, economic, and a little bit less robust. So many people, when they envision a larger project, they shy away from using the newer pixels that they're WS2812, which are commonly available. They lacking a clock line. They're less reliable in large strings, large arrays, and also they cannot be addressed by a simple controller like the Arduino. So, seeing that most of you aren't programmers, I'll go back to our various controllers for any project that you'd like to do. We have an Arduino-based controller that is a shield that goes on top of the Arduino and allows for 4 inputs for changing anything you specify in the program, which can be brightness, hue, speed, intensity, and in this case, some sparkle. And so this box is just a housing for a reasonably fragile Arduino and a shield. And when we sell them, because my interest is making sure that everybody is up and running and seeing something beautiful, we always sell them with a program on there. So when you go to the Arduino library and start to look at the code, which is all I have ever done since I'm not a programmer, but I can read the comments and make some changes to the code and see how it changes the lights, and that's an exciting way to start Arduino programming, is to read the comments and see how to change, how little changes can change the lights. And we also have more straightforward, simpler controllers. This one is a radio frequency controller. It's quite tiny, and it listens. It has 300 modes, and requires no programming whatsoever, just a 5-volt power supply and a creative imagination for what your project will be. For larger projects, like the screen you see in our booth, we have software that is completely straightforward. I think there's probably a bright panel here that's making me hard to look at. This is running off of an SD card on a controller that holds up to 16 programs, and software that is completely simple to use, that you can drop in any video effect whatsoever and record it, save it to the SD card. You can do a live screenshot over a YouTube video with screenshot. So what to do? Let's see if I can find a YouTube video here. What to do? So, for example, exactly what is on the screen, obviously 16 by 16 is a fairly low resolution, but anything that is appearing on your screen is completely ready to go to the pixels. And we have a live box that runs off of a Ethernet feed. That one IP address can address 4,000 pixels, and that can run live out of any laptop. I think at this point I'll open it up to questions. If I'm up for super high-tech questions about packet content, and super simple questions like controller types and LEDs. We also have some beautiful diffusers and a line that totally did all the 3D layout work for the housing around our pixels, so you can do beautiful projects as well. Questions? Well, we're at the booth. The mornings are pretty intense, but we'll be there, and you can ask away and explore the possibilities. And all of our code is posted at coolneon.com as well. Let me switch here. And also, if you have a complicated and challenging project, it's our pleasure and obsession to help you out and work on them. The electroluminescent grand piano is a must-see. It's totally awesome. The programmer is right here, Zach. It's MIDI signal from the keyboard is addressing a due mille, and that's a Arduino type controller, and that's addressing 1,670 pixels inside of a Lexan grand piano. That's absolutely gorgeous. So the MIDI output from the keyboard goes to the controller, and Zach has created a gorgeous display of 88 columns of lights, and it's a must-see. It's an honor to have it here, and it was an amazing amount of work for the builder and the pianist to get it here, to get it to the Playa, which is where it debuted, and to bring it all the way in from Texas.
Totally worth it.
But totally worth it. Exactly. That's when it's a labor of love. It's something that you put amazing time into, and Coda, the pianist, if you're lucky enough to hear him play, he's just as beautiful. Yes. Boy, there's almost zero chance I can hear anything. It's always in sequence, but because the clock rate is so fast, you would address every pixel in sequence. So turning on the first light and the last light is a near instantaneous process of turning on the light, addressing no power to all the middle pixels, and then turning on the last light. And then the next frame, I would guess, would be the first two and the last two. So you could do a closure, but that would happen so fast that it's megahertz clock cycles. Absolutely. So every single one is waiting for the software to tell it what the 8-bit value for red, 8-bit value for green, and the 8-bit value for blue is. And in fact, our original TCL line also has another byte in there that is for checksum. So the light will not change from what it was last without confirmation that the data is perfect. So in all instances of static, like the Arc Attack that it runs a Tesla coil right next to our lights, we have never once ever had a white pop or a failure or any glitch that was visible. At most, one of the 30 frames per second in a pixel would be skipped, and then it would be right back to it if that static was generated. The WS series pixels run very well, but they're very susceptible to high EMF noise scattering.
Can you separate those out?
Oh, absolutely. In fact, the software, obviously, clever programmers, far more clever than myself, can do a layout that is they're doing the math to figure out exactly what's where. But this grid represents that grid. Another way to lay out the pixels is in the software that we provide for free with our controllers, or you can download it online anytime and play with it. But you lay out pixels in any shape you wanted. So if you were doing around a doorway, you could lay it out like this, make room for the doorway, and then the software knows exactly where each pixel lies. So when it does a rainbow, it would do the top of the threshold all the way down in the two left sides without skipping a beat, or if it was moving left or right, it would know exactly where each one was. Perfect. Our pixels are sold in the new ones are sold in 5-meter strips, but our normal line comes in 25 and 50 pixel strands with a connector on each end. So the pixels connect end to end to end without limit, literally without limit. And the only thing you need to do is add a little bit more 5 volts every 100 pixels or so. Sure, and in fact, we can, if we add a port to the software and get it ready to actually glow, when we analyze it, it turns all green, which indicates that every pixel has a channel going to it. And of course, if we were doing a real layout, we would map it exactly as we did the actual installation, and then that would be represented here. This is 159 pixels. The wires are labeled power, clock, and data. Yeah. But most clever people sort of choose blocks of 25 or 50. A grid I didn't bring is a 5x5 grid that you start thinking in blocks of 25s and 50s as you create. The screen in there is the larger screen is 50 pixels down and 25 across. And presently at the San Jose Museum of Technology, there's a 6-month installation of my screen that I created, and my friend Ping, who did the software for Truth is Beauty, has a hacked Kinect that identifies the location of your body and makes an aurora borealis array go across the lights. So it knows where you are, and you can push the lights around on a wall, and that's an install of 50 down and 25 across, and it's utterly astounding to experience that. It's a worthwhile trip to the San Jose Museum of Technology. And of course, programmers don't blink an eye at knowing exactly which to address, and they do layouts. So Truth is Beauty was 2,666 pixels. She was huge, and each pixel Ping knew where it was. So as he did mathematical pushes of light that rippled through her body, you could see the flows because he had identified the location of each pixel, even though they were going up in strands, up and down in strands of 50. These large-scale installations really inspire the soul. It is really an honor to be involved in so many beautiful projects. It's an honor to be here at Maker Faire. So thank you very much.